Hello scientific people, how are you today? Today we would be continuing our discussion on the Bohr's model and we would be deriving an expression for momentum, angular momentum and torque for an electron in the nth orbit for hydrogen-like atom. Suppose this is an hydrogen-like atom and Z is the atomic number, so plus Ze would be the charge on the nucleus. This is an electron, suppose its charge is minus E, we would be only considering its magnitude, and m is the mass. Suppose this is nth orbit, so this is n plus 1th orbit. We need not to discuss about n plus 1th orbit right now, so consider the nth orbit over here, and the mass of the electron is m. So talking about the linear momentum, linear momentum is represented by P, that is m times v. It's a vector quantity in the direction of velocity. So the velocity direction is shown over here. This is the direction of velocity, tangential. If this electron moves round and round like this, then that would be the direction of the velocity. And we already know the formula for the velocity that we have already derived in our previous lectures, that is E square upon 2 epsilon 0 h Z by n, where Z is the atomic number. So here we have an expression m E square upon 2 epsilon 0 h into Z by n, that is the formula for the momentum. And from here we can say that momentum of any electron in a given orbit, linear momentum, is directly proportional to Z by n. For a given atom it would be proportional to 1 by n, right? Okay, now let's talk about the angular momentum. So angular momentum, this was 1. Let's talk about the angular momentum now. Angular momentum is represented by L. It's a rotational motion quantity and it is always along the axis of rotation. So here if the electron is moving round and round, then the axis of rotation is from here towards you people. So a perpendicular line passing from the nucleus towards us is the axis of rotation, and that would be the direction of actually this vector. L is actually r cross p. R vector is shown over here. The p vector and v vector are almost in the same direction, because p and v vectors are in same direction. So if I actually pull this r vector over here, and then r cross p as per right hand thumb rule will be in the upward direction. So angular momentum vector is always towards the axis of rotation, upward or downward direction. Here it is in the upward direction, as we have considered the rotation of electron like this, revolution of electron like that. Okay, so let's again put the value over here. So it is equal to rp sine theta, where r and p have an angle of 90 degree between it. So we can just write down L vector's magnitude as rp into sine 90, that is 1, and p is the momentum vector, r is the radius vector. If you want to find the formula, we can also write down its formula as r, that is the radius, and radius expression we have already derived it. It is equal to n square h square epsilon 0 upon pi m z e square times the momentum vector m e square upon 2 epsilon 0 h Z by n, right? Okay, so you can find out by cutting it over here. So m gets cancelled, z gets cancelled, epsilon, h. Actually if you cut all those things, you will get the nh upon 2 pi only. So L is equal to nh upon 2 pi. We can directly also write down this as the postulate of the Bohr model. We need not to derive these things. L is directly nh upon 2 pi, very important relationship, and we can see that L is directly proportional to n, and it does not depend upon the type of element, right, because it is independent of z. So if you talk about the second orbit of helium or second orbit of neon, both of them, they are going to have same angular momentum, right? So L is proportional to n. Now the last one is the torque. Now torque only comes to the picture, tau, again a rotational motion quantity. This only comes into picture when an electron jumps from higher orbit to lower orbit, or an electron goes from lower orbit to higher orbit, right? Okay, suppose I consider this as the fourth orbit, n is equal to 4, and if I consider n is equal to 3. Now as per this equation, torque, we know that torque is equal to delta L by delta T. So delta L is change in the angular momentum when an electron jumps from 4 to 3. Suppose electron is jumping from 4 to 3, that means it is L4, angular momentum of 4 minus angular momentum of 3 upon delta T. So L4 would be equal to 4h upon 2 pi minus third orbit, so 3h upon 2 pi, divided by, you should be given the time taken by an electron to jump from n is equal to 4 to 3. So what happens is, this would be 1h upon 2 pi, or simply h upon 2 pi times delta T. The time shall be given to you, and if you substitute all the values, you can also find out the torque. It is again a vector quantity, comes in the rotational motion, and it is always along the axis of rotation, maybe in the upward or downward direction. So hopefully guys, you like my explanation, and do comment in the comment section for any doubts. And once again, I am telling you, there was no need to derive all this thing. You could have directly, we can also directly write down the formula of L is equal to nh upon 2 pi, as this is the postulate of Bohr's model. So if you like my explanation guys, please do subscribe to my channel and keep tuned. Thank you for watching the video.